All right, guys, I just wanted to give you a quick walkthrough of your PhET simulator. It's called the speed of a mechanical wave. So I kind of split my screen here with the worksheet on the left side and the simulator on the right side. So if you click this link at the top, it'll take you to the website over here on the right. It's a simulator to make waves. Okay. So what we're going to do here is the purpose is to find the speed of a wave by two methods. Okay. The first method you use is something we've seen before in the last unit, velocity equals distance divided by time. So I'll talk about that one first, and I'll just show you how to get the simulator set up. Okay. So that's really important because I've gotten a lot of questions on this. If you look here for under simulation settings, there's all these things. So let's go through and do that. So it lists all the things that the simulator needs to have. Okay. So pulse, if I look over here, there's manual, oscillate, and pulse. So I want to switch it to pulse. I want to bring up the timer, and there's checkboxes down here in the simulator. There's a timer checkbox here. We want a fixed end. It's already on fixed end. We want an amplitude of 0.75 centimeters. That's already set up for us. We want to switch it to slow motion. So you see normal and slow motion here. I'll switch it over to slow motion. Dampening, we want none. So that's the slide bar down here under dampening or damping. I want that to be all the way at none. We also want a pulse with 0.5 seconds. That's already set. Okay, and then there's one more thing. It says ruler here, so we want to check that ruler checkbox. And then a ruler will show up on your simulator. Okay, so once you have that all set up, you should be able to go through and start answering, start filling in the boxes. All right, guys, now that you have your simulator all set up, you can start filling out the table. Notice this tension column, this first column. It's high, mid, and low. That's just a setting that we're going to change on our simulator here, but it's going to be on high for the first three. And then let me show you how to do this. So the number of passes, a pass is when a wave passes a certain point. We can think of it, though, as all the way down the rope is going to be one pass, and all the way back will be a second pass. Notice how I put in 7.5 centimeters for the length. That's just looking on this ruler here, the length of this string from 0 all the way to 7.5. That should be the same for all of these, but we'll go through some. The kind of a tricky part will be timing it. So you see there's a timer. You can use your phone as a timer. You don't have to use the timer on the simulator. I'm actually going to move the timer like right by this green button because that's how I'm going to make the wave. So since it's in slow motion, I'm going to quickly try to push both at the same time. So here we go. I'm doing 2 passes for this one, and then I have to put the distance. So let me start it. So you can see my timer's running all the way down the string. There's 1 pass. It comes back, and I want to stop the timer right when it gets back. Okay. So my time there was 2.26 seconds. And restart the simulator, you just press the restart button. My distance is the length times the number of passes. So if the length is 7.5 down the rope, 2 passes down and back would be 7.5 times 2, right? And 7.5 times 2 is 15 centimeters. So now I'm ready to finish this row, okay? The distance is 15 centimeters. The time is 2.26 seconds. If I divide those, so let me pull out my calculator. If I do 15 divided by 2.26, I get 6.64. And that's going to be in centimeters per second. You don't have to write in the units because it's already shown up here at the top. But now you've got the first row, okay? Then you'll repeat it for the next ones. Okay. So let me just do one more. Let's see. I'll do the mid-tension one here. So let me reset my timer. Let me change my tension to mid. Okay. I'm going to do 2 passes. So you just run the simulator again. Down one way, that's 1 pass. When the beginning of this wave gets back, that's going to be 2 passes, okay? So I got 3.91 that time. So same length, um, same distance. And this instead, the time this time with the mid tension was 3.91. Then I'm going to do 15 divided by 3.91. And I get 3.83. Okay, so that's how you're going to fill out the first table. All right, guys, I'm just going to walk you through part 2 of the PhET lab, or method number 2. You have to make a few settings changes. Okay, so the last time it was on pulse. We want to change it to oscillate, as it tells us here in the instructions. We want our amplitude to be 0.1 centimeters. So I had to move this bar till it was at 0.1 centimeters. And what we're going to do is we're going to create a standing wave with the frequency listed. Then we have to count the number of segments and complete the chart. So a standing wave is a wave that it doesn't look like it's actually moving along the string. It just kind of looks like it's standing still almost, or just moving up and down. So let me kind of show you what it looks like. So this is a standing wave. It's going to keep getting bigger. But notice how it doesn't look like the wave is actually traveling down the string. You just have the troughs and the crests just kind of going up and down. So that's a standing wave. And you can pause it. And as you can see, it's just one total wavelength in this case. So for the first row, you want to make sure you set your frequency to 0.83, which I already did. See how my frequency here, 0.83 hertz. The number of segments is like the number of crests and troughs. So if you look over here at the simulator, um, it's kind of like this is one segment here, this trough is one segment, and this crest is another segment. Okay, so I actually have 2 segments for this first row. The length again is going to be 7.5 for all of these as you move down. And that's just because we see it on our ruler here. The wavelength, we have a calculation here to do the wavelength. It's going to be 2 times the length divided by the number of segments. So here's our length, right? And here is our number of segments. So in this case, we're going to do 2 times the length. Okay, so that's going to be 15 divided by the number of segments is 2. So our wavelength, if you do 15 divided by 2, our wavelength is, switch. So our wavelength is actually 7.5 centimeters, which makes sense because if you look at the simulator, this is one complete wavelength. It's the length of the 7.5, right? So remember, for a wavelength, it's a complete trough and a complete crest. So this is just one wavelength on this string here. Okay, if you think back to that counting waves assignment we did. So then we got to calculate velocity. And let me erase this stuff. Okay, so velocity is just going to be frequency times the wavelength. So the frequency here is 0.83. Wavelength is 7.5. So I have to do 0.83 times 7.5. Okay. Let me throw that in my calculator. Um, and you get 6.2. Not working. You get 6.23 centimeters per second. Okay. So let me just do one more here. Again, I'm going to keep the tension on high. It's already there. I need to change my frequency to 1.67. So let me change my frequency here with this slider. Okay. I want to reset the wave. Now I'm going to press play. And a higher frequency means that there's going to be more waves, right? So I've got a standing wave, and I'm just going to pause it when I've got a good standing wave. Okay. So then you want to count the number of wave segments. So we've got 1 here, 2, 3, and 4. So it's really like the number of humps. So you've got 1, 2, 3, 4. So 4 wave segments on this one. Again, the length is 7.5 centimeters. Wavelength, we're going to take 2. Again, we're going to, just another calculation here. So it's 2 times the length, which is 15, divided by the number of segments, which is 4. So 15 divided by 4 gives you 3.75. Okay. Then we need to calculate our velocity. So we're going to do frequency times wavelength. So our frequency is 1.67 times our wavelength, which is 3.75. So let me put that in my calculator. I get 6.26. Okay. Pretty similar to the first one. So hopefully that'll help you guys fill out the second table. Okay. Then you'll have 4 questions. Okay. So number 1 is going to be, does changing the frequency change the speed of the wave? You're just going to have to look at your data and see where you change your frequency. So we change our frequencies. Is that affecting the speed of the wave? It doesn't look like a whole much for the first 2 we did, but you'll just have to go through and see. Does changing the wavelength change the speed of the wave? So here we have different wavelengths. Doesn't look like it has a big effect on the speed of the waves, but I haven't completed this whole table yet. Okay. 3, does method 1 and 2 give the same wave speed? You'll have to look at, by method 1 and 2, they mean page 1 and page 2. And what had the greatest effect on the speed of the wave? Okay. So get this completed. Let me know if you have any questions. Again, it's not due till the end of the day, Wednesday. So good luck. Let me know if you have any questions, and we'll talk to you later.